Hello, this is the luckiest maths teacher in the world. Today we look at powers of matrices, but this is really just a bit of an extension of what we were doing when we multiplied matrices. So firstly, let's just have a look at what a power is. So let's look at numbers. So we know if we have 3 to the power of 4, for example, we multiply this number this many times. So that's 3 times by itself 4 times. Now the same works for a matrix. If I have a matrix A and I raise it to a power, let's say 2, I multiply this many times. So I'm going to multiply A by itself. Now what makes this a little more complicated than numbers is you can't always do that. So let's say A was, let's say this matrix here. So 1, 0, 5, negative 2, 6, 8. So A is, of course, a 2 by 3 matrix. But if I want to multiply A by A, then that would be a 2 by 3 matrix times a 2 by 3 matrix. I can't do that because these two numbers are not equal. In fact, the only way these two numbers will be equal if you're multiplying a matrix by itself is if these are the same, if A is a square matrix. If A was 2 by 2, I'd have no problem multiplying it by itself because these would be the same. If A was 3 by 3, I'd have no problem multiplying A by itself because these two numbers would be equal. So you can only take a power, or a power more than one, like squaring, cubing a matrix, etc. You can only do that for square matrices. You can't square a matrix unless it is a square matrix. So let's go ahead and look at some examples. So let's make up a matrix here. So x equals, let's say, 1, 3, 0, minus 1. So x squared would just be this matrix of x multiplied by itself. So this is essentially just matrix multiplication. So we have a 2 by 2 matrix multiplied by itself. These two numbers are equal, so we can do it. The resulting matrix will be this size, 2 by 2. So as I said in a previous video, I think the easiest way for you to do it would be to draw up your product matrix, put in some boxes, and we'll fill them one by one, what goes into them. So x squared is just x times by itself. So the one that goes here, row 1 by column 1. So what we need to do is pair up the elements. So 1 times 1 plus 0 times 3, of course, just gives you 1. The entry here is row 1 of the first matrix by column 2 of the second matrix, across by down. So the way we get that, 1 times 0 plus 0 times minus 1, which is just 0. So entry down here, row 2 of the first matrix by column 1 of the second matrix. So 3 by 1 minus 1 by 3, and that of course gives you 0 as well. And then the final entry is row 2 by column 2, so that will be 3 times by 0 plus negative 1 times negative 1, and that gives you 1. Okay, now hopefully you see that this is a special kind of matrix called the identity matrix. And remember, we talked about the identity matrix is special because if you multiply any matrix by this, then it doesn't change it. So let's say we wanted to figure out x cubed. Well, using our index laws, that's just the same as x squared times by x. So we know what x squared is. We know that it's 1, 0, 0, 1. So we just need to times it by our original matrix, which is 1, 0, 3, negative 1. So as I told you, however, multiplying by this doesn't change the matrix. So I know straight away that x cubed is just going to be this here, because multiplying by this doesn't change it. So that's how you'd figure out x cubed. So if you're ever asked how to find a matrix cubed, find what the matrix is squared, and then multiply it by the original matrix. Alright, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.